So continuing on with the periodic table and some other information that we need to be able to do or label or find on our periodic table. One thing, of course, is being able to identify, we call this the regions, the metals, nonmetals, metalloids, regions. So over here in orange, of course, all of these elements are considered metallic or metals. Okay, so back here looking at the regions on the periodic table, we have orange for metals, yellow for nonmetals, and the green for the metalloids. And of course, they want you to label them, so you can move these over, and I can flip this a little bit and kind of line it up. We call that the staircase, by the way. And pretty much you can consider all of these ones along the staircase to be metalloids except for aluminum. Aluminum is definitely falls into the metal category. Now, metals, of course, are the majority of the elements on the periodic table. All of these orange ones, all of them are in the metallic category. And then the yellow ones here, these guys are the nonmetals. And don't forget hydrogen. Once again, they position that over the alkali metals because it has one valence electron. But it is a nonmetal in its properties, so we want to make sure that you understand that. So hydrogen, helium, and then all the other ones over here to the right of the staircase are considered to be nonmetals. The ones left of the staircase and down below, because really these two rows insert right here, make the periodic table very wide. Those are all considered metals, and then these ones on the staircase. Now, it is up for debate whether polonium and acetine are considered that's AT and PO here, metalloids. Some may argue that polonium is a metal. Some may argue that AT is a nonmetal. For our purposes, the ones that I really want you to know as metalloids, though, are tellurium, antimony, arsenic, germanium, silicon, and boron. Those are the main ones, those 6, that you really need to be able to identify as a metalloid. So when you see a periodic table, you should pretty much be able to determine if it's a metal, nonmetal, or metalloid. Now let's look at the properties, and I changed a couple of them, so you might want to go up here and add a text box, or I'm sorry, I didn't do text box, I did the shape thing, I did this one. I added a shape to put over it, because I felt like that it's a better descriptor to say that these are poor conductors of heat and electricity, tend to be brittle, dull. Many are gases at room temperature, not able to react with acid. They gain electrons and become anions, which are the negative ones, right? So these would be the characteristics I identify as one of these groups up here, the metals, the nonmetals, or the metalloids. So does anybody want to take a shot as to which these characteristics and properties identify which group? Metals, nonmetals, metalloids. Good, yes, I agree with you. I would say these apply to the nonmetals. Very good. And usually the metals and nonmetals are kind of opposite of each other in terms of their properties. So, good conductors of heat and electricity, malleable, ductile, shiny, lustrous, able to react with the acids, lose electrons, become positive or cations. Yeah, opposite here. So they're going to be your metals. Good. Now, this is where, like I said, I changed this because it really should say semiconductors of heat and electricity. Mostly they're semiconductors because they can conduct a little bit of electricity without usually all the heat, but we could label them, or you could just, let's just put it this way, you could just put them as semiconductors. I think that's probably a better way to label them. Metalloids, it really is dependent on each individual element because each metalloid is going to be different in its properties. Some metalloids are shinier, some are dull. Some conduct electricity well, some don't. You know, some are brittle Some can gain, some can lose electrons. They have the in-between properties, but it's really dependent on the particular element that you're talking about as to which metallic properties it has, which non-metallic properties it has. So this is what I would put here. I'd put semiconductors because usually that falls into that particular category, and being able to arrange them correctly. Now the next slide wants you to do some sorting, taking some of these and put them in their respective categories. Is it a metal, a non-metal, or metalloid based on the description in the little box. Now you should be able to move these. If you click on them, then you can, move these around and sort them into their correct respective category. I'm going to give you like a minute or two to do that. Okay, so poor conductors, where am I going to put that one? Which category? Yes, over here to the non-metals. And since this one here, let's see here, let's take a look. Hydrogen also belongs over here in the non-metals. Aluminum, of course, goes over here in the metal category. And malleable, where it can be pounded into sheets and formed into other shapes, that one would be a metal characteristic. Halogens, all of those are in the non-metal category. Silicon is on the staircase, so it is going to be a metalloid. Period 2, group 2. So let's look here. Period 2, group 2 happens to be beryllium. So I'm going to put that one in the metal category. Oh, period 4, group 15. Let's take a look. Period 4, all the way over here, group 15. Oh, that's arsenic. It's on the staircase with the metalloids. So we would put that there. I'm going to take that and put that over here. That's arsenic. Great conductors, definitely in the metal category. Dull, non-metal category. Some are brittle but ductile. That would be like mixture of traits, so I put that in the metalloids. Mostly gases at room temperature are the non-metals. Hydrogen, of course, is a non-metal. And then, period 3, group 18. Period 3, group 18 happens to be argon. So that one is going to be a non-metal. Good to go on that, being able to sort. Few other points here are the states of matter of certain elements at normal conditions. So when I'm talking about normal conditions, I'm talking about like room temperature, which is somewhere between like 71, 72 degrees-ish. And then normal conditions would be 1 atmosphere, which is the atmospheric pressure at sea level. So we're right around 1 atmosphere here in Northern Virginia. And we have that same kind of pressure system, but at normal conditions, the few ones that are liquids on the periodic table are mercury, which is the metallic liquid, and bromine, which happens to be the non-metal liquid. Those ones are really the only ones I want you to identify as liquids at normal conditions, which would be considered what we're normally at. The ones that are going to be gases, most of your nonmetals are gases. You have hydrogen over here, and then it starts with nitrogen, oxygen, fluorine, chlorine, and then the noble gases. Remember, bromine is a liquid. These other nonmetals here, carbon, phosphorus, selenium, iodine, and sulfur, those ones would be considered solid at room temperature. So there's a few nonmetals that are solid at room temperature. Mercury, which is right here, Hg, that one's your metallic liquid. Bromine, your non-metallic liquid. All of these red ones being your gases at room temperature, which are mostly are all the nonmetals there. And then a few other things about solids to classify the rest of the solid category. Metals are all solid except for mercury. The metalloids on the staircase are all solid at normal conditions. And then the solid nonmetals are iodine, selenium, sulfur, phosphorus, and carbon. So that's the last couple of things that I want you to be able to identify on the periodic table.